Good evening to all of you. Welcome back to another session of Chemical Morning. Another session of Chemical Morning where we are going to discuss about the ionic bond formation, right? Ionic bond formation, which already we started our discussion, right? Okay. So as we discussed already that the primary requirement for the ionic bond formation is one atom should be capable of donating the electron, and the second atom should be capable of accepting the electron or gaining the electron. So, who is losing the electron? We call it as a donor, or this is nothing but a metal. And who is accepting the electron? It is called an acceptor, right? Or gainer. We also call it as a gainer, right? And generally gainer or acceptors are nothing but non-metal. That's it. An ionic bond is formed between your a metal and a non-metal. This is the primary requirement or prerequisite condition to form an ionic bond. An ionic bond cannot form between two non-metals. An ionic bond cannot form between two metals. So remember that again I am telling ionic bond cannot form between two non-metals. It cannot form between two metals also. In metals, we find another bond which we call as a metallic bond, right? Which is the strongest bond among all the type of bond what we are going to discuss. Yeah, the time yet to come or they will come, right? So among all the bonds, metallic bond is the strongest bond. Remember, or strongest. Yes. Mansa, right? Okay. So your the primary requirements for the ionic bond formation is one should be a metal, one should be a non-metal. That's why such kind of combinations are because of ionic bond. And we discussed yesterday the mechanism. That mechanism I did not erase it because we are going to discuss some more example here. What is the mechanism? The first is your fulfillment of primary requirement. Means one must be a metal, second one must be a non-metal. Second one, formation of cation, that is positive ion, by losing the electron and achieving the nearest inner gas configuration. Third point, formation of anion, that is negative ion, by gaining electron, right, and achieving the nearest inner gas configuration. The fourth point is holding the two ions by a strong electrostatic force of attraction. This electrostatic force of attraction, which is holding the two ions together, we call it as a chemical bond. Right? Okay, then we are going to draw the structure. So let us take one. Yesterday we discussed about how NaCl is formed. So let us go for the discussion about formation of. Okay, second example I am writing formation of magnesium oxide. Let us take formation of magnesium oxide. Right. So how the magnesium oxide is formed? How the magnesium oxide is formed? Okay. So here, which element is reacting with what you take here? Right. So here, the first point is the magnesium reacts with oxygen to form magnesium oxide. So magnesium is a metal, amide. Oxygen is a non-metal, so NMide. So primary requirement is fulfilled. Primary requirement is fulfilled. Okay, coming to the second step. What is the second step? So magnesium, the atomic number is 12. So electronic configuration, what I have to write the electronic configuration? Now I can write here but as it is 12, neon as a configuration, so neon 3s2, neon 3s2. That means I can write it is a 2 comma 8 comma 2. So it is 3 cells, outermost consists of only 2 electrons. Okay. So because it has 2 electrons, so it has a tendency to lose how many electrons? 2 electrons, because it is alkaline earth metal, group valency 2. So it has a tendency to lose 2 electrons. Okay, right. So the magnesium, what it will do? Now it will lose 2 electron and it will form magnesium 2 plus ion. Magnesium 2 plus ion. The initial configuration in the normal state, that is 2 comma 8 comma 2, and 2 electron gone. So all the 2 electrons gone. So what is the new configuration achieved by the magnesium? That is 2 comma 8, which is the nearest inert gas configuration of neon. So the stability is increased now. So magnesium ion has more stability than pure magnesium. Okay, so formation of cation and achieving the nearest inert gas configuration over. Next, coming to the oxygen. So oxygen atomic number is 8. So if I am writing the electronic configuration, so what I have to write? Now helium configuration, that is 2 gone, remains 6, means 2s2 and 2p4, 2s2 and 2p4. That means if I am writing the configuration 2 comma 6, so in the outermost how many electrons are there? 6 electrons are there. How many are there? 6 electrons. So it is shortage of 2 electrons for the magic configuration. Magic configuration is 8, achieving the 8 electron, right? So it is shortage of 2 electrons. That's why it cannot lose electron. Other than that, it will gain the electron. So that's why oxygen, it is shortage of 2. So it will gain 2 electrons. From whom it will gain? From the magnesium only. From the magnesium only. Right. And it will form O2 minus ion. O2 minus ion. So initial configuration is 2 comma 6. By gaining more 2 electron added. So 2 comma 8. And it is achieving the nearest inert gas configuration of neon. Right. So both oxygen 2 minus and magnesium ion are now stable. So now your magnesium 2 plus ion, it come close to the oxygen 2 minus ion. Now what will happen? And they will attract each other because both are di positive and di negative ion. So they will be strongly held by electrostatic force of attraction. So electrostatic force of attraction will hold on. Here charge is very high. Charge is very high. So they will hold each other and they will form what? MgO, magnesium oxide. What it will form? Magnesium oxide. So now if you want to draw the structure, what you have to draw? Magnesium has how many? You take 3 cells are there. So nucleus, first cell, second cell, third cell. So this is our magnesium. Now, oxygen has only 2 cells, 1 and 2. So now, draw the electron which are present. So magnesium has 2 electrons in the first cell, 8 electrons in the second cell, and 2 electrons in the third cell. Whereas oxygen, this is your oxygen. As how many you check here? The first cell consists of 2 electrons, second cell consists of 6. So 1, 2, 3, 4, 5, and 6. So now magnesium, what it will do? Now it will donate. It will donate. So make the 2 electrons to jump. So one jumping and second jumping. Right. So electron jump from magnesium to, or magnesium will donate 2 electrons to oxygen for the octet configuration. So then what will happen now? Now magnesium third cell gone. So remain only 2 cell now. So first cell and second cell. Right. which is a positive entity now. This is a positive entity, right? And the second one, which is a negative entity, that is also oxygen, which has also two cells, but number of electrons are different. What is that? Now here, your this is your magnesium 2 plus. Magnesium 2 plus. This is your oxygen 2 minus. Right. So it has
Sir,
a two electrons. Yes.
sir, on
Tell
what
me.
factor that enthalpy depends, sir?
Enthalpy we have not discussed at all. The yet to come. Okay. Yet to come.
Yes, sir.
Please wait for some time. Enthalpy means energy changes during the reaction. Why certain reactions are exothermic, why certain reactions are endothermic. When the energy changes, we are going to discuss after this is ionic bond is going on, then we will we'll go for covalent bond. Under covalent bond, we are going for non-polar, polar. Then when we are going to discuss about the structure of the covalent compound, then enthalpy will come there. Got the point? We are a premature state. Remember, we are premature state in the chemical bonding. So many things yet to come. So many things yet to come. So please hold your breath. Okay. So please. Right. Okay. So the first cell of magnesium consists of two. Second cell consists of 8 electrons. Right. Here the first cell consists of two electrons. Second, by gaining two, so it also have 8 electrons in the outermost. So it will form now your magnesium oxide. Magnesium oxide. Right. So this is the formation of magnesium oxide. Now, if I take another example, like if I take aluminum chloride, AlCl3, AlCl3. So formation of aluminum chloride. So what do I will do? Now here only I have to change. So what are the thing I am going to change? You check here. See, nothing I am going to do here. Only I am going to change here something because the process is same. Process is what the same. So here what is that? The formation of aluminum chloride. So aluminium is reacting with the chlorine and forming AlCl3. Forming AlCl3. So aluminium is a metal, chlorine is a non-metal. So our primary requirement is fulfilled. Okay. So the next point is which element it is? Aluminium. So aluminium means the atomic number is now 13. I am writing here. This is a 13. Right, after magnesium, aluminum. So here what I have to write here? Now here I have to write here 3s2 and 3p1. That means 2 comma 8 comma 3. So it has the 3 electron in its outermost. 3 electron in the outermost. So that's why aluminum will lose how many electron? 3 electron. Then it will form what type of ion? That is your okay. So aluminum now it will lose the 3 electron and it will form Al3 plus ion. So initial configuration is 2 comma 8 comma 3. Right. 3 electron lost. So remain 2 comma 8, which is the nearest inert gas configuration of neon. Okay. So first point is over. Next is coming what the chlorine. Next is coming what the chlorine. So how many chlorine is participating here? You observe 3 chlorine because each chlorine has capacity to gain 1 electron only. 1 electron only. So that's why your 3 chlorine. Right. So your 3 chlorine. So one chlorine has atomic number is 17. Electronic configuration I can write neon as a 10. So neon configuration along with 3s2 and 3p5. So that means 2 comma 8 comma 7. So it has a 7 electron in its outermost. So that's why each chlorine will gain how many electron? Now only one electron. And to form your what it will form? Now each chlorine is gaining one electron to form Cl minus ion. Right? Initial configuration was at 2 comma 8 comma 7. Now 2 comma 8 comma 8. That is the nearest inert gas configuration of argon. So 2 comma 8 comma 7 by gaining one electron, that becomes 2 comma 8 comma 8, which is the nearest inert gas configuration of argon, that is 18. Right. So now your the aluminum will combine by electrostatic force of attraction. So what will happen now? Now Al3 plus 3Cl minus, it will form AlCl3. So strong electrostatic force of attraction will hold the two ions together. So now if you want to draw the structure, the structure will be little different. Structure will be little different. So let us draw the structure. Okay. And rest of the things you can practice. So that is your homework. So this is your homework. You try. This one you try. Next this one you try. This one you try. Right. Formation of this molecule you try. Okay. And try with MgCl2. MgCl2 try to write in the same way. Try to write in the same way. So these are your homework. Okay. So practice your home. So now the structure. So how do you check the structure? Now you check aluminum. So how many chlorine are there? 3 chlorine. So you can put the aluminum as a center. Aluminum as a center. So aluminum has how many you see? 3 are there. So I am keeping there are 3 cells. Right. So this is your aluminum. Next is your chlorine. It has also 3 cells. So I am putting here one chlorine. Right. And second chlorine. This is one chlorine, second chlorine, and the third chlorine this side. You can arrange according to your choice. There is no hard and strict rule about this. Okay, you can put here anything. So aluminum 2 comma 8 comma 3. So 2, 8, and 3. So 1, 2, and 3 because I am going to donate it. Now chlorine has how much? 2 comma 8 comma 7. So 2, 8, and 7. Same 2, 8, and 7. Same 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So now one electron you have to make it to jump. So aluminum will donate like this. One electron here, one electron here, and one electron here. So this is the transferring of electron takes place from aluminum to 3 chlorine. So that's it. What will happen? That will form your, so what it will form? It will form Al3 plus along with 3Cl minus. So it will form AlCl3. Right. So this is the mechanism. So once you understand about the mechanism, you can write enough number of example in the similar pattern. Got the point? So this is our formation of ionic bond. Formation of ionic bond. Okay. Now the compound which are formed. So you can observe here because electrostatic force of attraction is holding the two ions together. Electrostatic force of attraction is holding the two ions together. That's why this is called the electrovalent bond. What bond we call? Electrovalent bond because strong electrostatic force of attraction holding the two ions together. That's why we call it as a electrostatic bond or electrovalent bond also we call. Right. Similarly, it is also called as ionic bond. It is also called as ionic bond. Why? Because ions are participating. So here you check. This is ion. This is also ion. Right. All these are ions. Ions are participating in the bond formation. That's why we call it as a ionic bond. So ionic bond. Your other name of ionic bond are ionic bond, your electrovalent bond, electrostatic bond also. So you can practice how the potassium oxide is formed, how the calcium chloride is formed, how the potassium chloride is formed, how magnesium chloride already we discussed, sorry, not discussed, so how the magnesium chloride is formed. In the similar manner, you write all these 5 points. Remember, first is the fulfillment of the primary requirement. Second is the formation of the cation by losing electron, achieving the nearest inert gas configuration of hydrogen or argon something. Third point, formation of the negative ion by gaining the electron, achieving the nearest inert gas configuration. Then electrostatic force of attraction holding the two ions together. And last point is your structure. Last point is your structure. So this is the mechanism. This is the mechanism for formation of ionic bond. Formation of ionic bond. Right. Okay. So now the compound which are formed, the compound which are formed by ionic bond are called ionic compounds. So what are ionic compounds? The compounds or molecules which are formed by ionic bond are called as ionic compounds, such as magnesium oxide, sodium chloride, right? Magnesium chloride, aluminum chloride, potassium chloride, calcium oxide. All these are the compound belongs to ionic compound. So what are the ionic compound? The compounds which are formed by ionic bond, which are formed by ionic bond are called ionic compounds. So let us discuss about the properties of ionic compounds. Properties of ionic compounds, how they look like. How they look like. Okay. Right. So next is here the ionic compounds. Ionic compounds. So what are the ionic compounds? The compounds which are formed by ionic bond is called ionic compounds, such as your magnesium chloride, aluminum chloride, potassium chloride, right? Sodium chloride. Next, sodium oxide, Na2O. Next, magnesium oxide, magnesium oxide. Then potassium oxide, so K2O, calcium oxide. So all these are nothing but called ionic compounds, which are formed by ionic bond, which are formed by ionic bond. So now what are the properties? Let us find. So properties of ionic compounds. Ionic compounds. Right. So what are the properties? So first point we want to discuss about first point about nature. So what is the nature? What is the nature? Okay. So you are eating everyday salt that is called common salt, which is our NaCl, which is our NaCl. So how it look like? Does it liquid state, solid state, or gaseous state? You'll say, sir, salt we are eating,
Glacier.
salt always. Ah, tell me.
Glacier.
It is gaseous state. The salt you are eating every day, that is gaseous state. What a great answer.
Sir, semi-solid.
Yes, very good. So sodium chloride is solid means all the ionic compounds are in solid state only. Most of the ionic compounds are found in a solid state. So generally they are very hard, very hard and rigid. Rigid means you cannot, some ionic compounds are there whose shape and size in normal way you cannot change. In normal way you cannot change. That is called its rigidity property. So they are very hard. Why they are very hard? Because the strong force of attraction is holding together. Like you, when you hold your friend very tightly. So what happened? Now, if the third friend will come into it, he cannot break it. He cannot break your bond. So that's why it is very strong. So generally, ionic compounds are very hard in nature and they are rigid in nature. In normal condition, their shape and size cannot be changed in a normal means. So this is the nature. Second point is the state. Second point is the state in which they exist. So generally, all the ionic compounds they exist in solid state. Okay, so they exist in solid state. So most of the ionic compounds, all the compounds, whatever I wrote here, all exist in a solid state. Okay. The third point about the structure. So what is the structure of these compounds? Generally, whenever the sodium chloride is formed or any ionic compound is formed, any ionic compound cannot form in one molecule. One molecule doesn't form. So it forms multiple number of molecules or you can say infinity number of molecules at a time form, which we call as giant molecule. What do we call it? A giant, very big. So that's why. So all the ionic crystals or all the ionic compounds found in crystal form, found in what the crystal form. Like one of the example I'm talking here, NaCl. So how the NaCl is found? How the NaCl is found in the nature? So you might have observed that seawater, whenever we are harvesting the salt from the seawater in especially Karnataka and Tamil Nadu region. So huge quantity of salt at a time form, you might have observed that. Okay, that we call as a salt meadows or salt hills also we call it. Right. So in the formation of sodium chloride, it does not form a single one. So how it will form? Now it will form a giant molecule in a three-dimensional array. Three-dimensional array means each sodium ion it will be surrounded by six number of okay. So each sodium ion here it will be surrounded by so this is your sodium ion. This will be surrounded by six number of chlorine minus ion. Chlorine minus ion, and each chlorine ion will be surrounded by. So here I am drawing again. So this is about chlorine ion. So this will be surrounded by six number of sodium plus ion. Sodium plus ion. Right? And it will form a crystal. It will form a crystal like a simple cubic structure. If you talk about a simple cubic structure, so it will be like this. Going to draw it here. So don't worry. Right. So here you can observe here. Each sodium ion is surrounded by one, two, three, four, five, and six number of chlorine ion. And each chlorine ion is surrounded by one, two, three, four, five, and six number of your sodium ion. So that's give rise to a crystal like this. So this is a simple cubic crystal. Simple cubic crystal. So this is called a crystal lattice. We call it is a crystal lattice. This is a simple cubic crystal. Right. So this your one if I'm taking this is the sodium plus ion, sodium plus ion. So this will be here. This will be Cl minus, right? And this will be Cl minus. This will be Cl minus, and up will be Cl minus, right? Up will be Cl minus, and the direction one, and the direction one. Another Cl minus will be here. Right. Similarly, this chlorine will be surrounded by this sodium plus, again sodium plus here, again sodium plus here, here down another sodium plus, and the back side, your another sodium plus, and another sodium plus here. So you can observe here 1, 2, 3, 4, 5, and 6. So here chlorine is there means another sodium plus will be here. So sodium plus means this will be chlorine again minus. So like that, it will form a three-dimensional RE, three-dimensional RE of a crystal. So this is called crystal lattice. What we call it? The crystal lattice or three-dimensional arrangement of crystal. So this is one crystal and this is second crystal. Like that, it will go on formation. So one by one crystal, it will go on formation. Right. So this is called a lattice. What we call it a lattice. Right. Crystal 1, crystal 2, and crystal 3. So all these are formed like that. So it forms a very giant molecule, very giant molecule. So that's a the structure of all the ionic compounds are three-dimensional. I'm writing 3D crystal lattice. What we call it a three-dimensional crystal lattice. Three-dimensional crystal lattice it will form. Right. So that is called the three-dimensional arrangement of the ions in a simple cubic structure. This is a simple cubic. Of course, there are so many type of structures are there, but it is called a simple cubic structure. We call as a SCC. That is called a simple cubic structure. So this is the structure over. Next, point number 4 about the melting point and boiling point. So generally, your water generally because the electrostatic force of attraction is very strong, and this strong force it held the two ions together. So you cannot break it easily. You cannot break it easily. So when you break that, it will convert into liquid because in liquid the force of attraction is less in comparison to solid. That's why more quantity of energy is required to break this bond. More energy is required to break this bond. That's why they have very high melting and boiling point. Melting and boiling point. Okay, so this is the fourth point. The fifth point is conductivity. The fifth point is conductivity. So what is conductivity? Neither thermal conductivity or electrical conductivity. Thermal conductivity or electrical conductivity. So generally they are your bad conductor. They are bad conductor in normal state. In what state? The normal state. Because no free ions are available. No free ions are available. That's why they're bad conductor in their normal state. But they're a very good conductor. Yeah, very good conductor in their what a molten state. What state? Molten state or dissolved state. Dissolved state. So why this we are going to discuss tomorrow again. Okay, this point because we have left side. Okay, so this is the fifth point. And the sixth point is about the solubility. So generally, all the ionic compounds are soluble in polar solvent. What solvent, sir? Polar solvent. So what is a polar solvent? That is like our water. What is a polar solvent? HCl, HBr, all are polar solvent. Okay, so that we are going to discuss this point and this point. Fifth point and sixth point tomorrow we are going to discuss. Now,
Sir,
if you have any confusion, you can ask. Yes, tell me.
sir,
Yes, tell.
sir.